By the end of the lesson, the students will be able to explain the terms rate equation and order of reaction, deduce that a reaction is a zero-order reaction from its concentration time graph, and state the integrated rate expression for a zero-order reaction. Acidified potassium manganate 7 solution is decolorized by iron 2 sulfate. A small quantity of iron 2 sulfate takes a longer time to decolorize the solution than a larger amount. Why is this so? Click next for the answer. Answer. This is because the rate of the reaction increases with an increase in the concentration of iron 2 sulfate. The rate of a chemical reaction may depend on the concentration of either one or more reactants. We can determine the effect of the concentration of each reactant on the rate of reaction if we know the rate equation for the reaction. Click next to find out more about rate equations. For the reaction A gives X, the rate is proportional to the concentration of A. N is called the order of reaction with respect to A. It shows exactly how the rate is affected by the concentration of A. The value of N is usually 0, 1, or 2. We can express the relationship between the rate and the concentration of A in the form of the equation rate equals K times concentration of A to the power of N. This equation is called the rate equation or rate law. K is called the rate constant. The rate equation or rate law is an expression which relates the rate of reaction to the concentration of the reactants. For the reaction A gives X, the rate equation is written as rate equals K times concentration of A to the power of N, where N is the order of reaction with respect to A and K is the rate constant. The order of reaction with respect to a reactant is the power to which the concentration of that reactant is raised in the rate equation. N is usually 0, 1, or 2 and shows exactly how the rate is affected by the concentration of A. Let us look at the case of a reaction where the value of N in the rate equation is 0. We say that the order of reaction with respect to A is 0. Click the graph button to view the concentration time graph. The concentration time graph of a zero-order reaction is a straight line as shown. What does the gradient of the line tell you about the rate of the reaction at different concentrations of A? Click next for the answer. Answer. The rate of the reaction is the same at different concentrations of A. This shows that the rate of the reaction is independent of concentration of A. As the concentration of A to the power 0 equals 1, the rate of the reaction is equal to K. The gradient of the graph is therefore equal to minus K. A graph of the rate of the reaction is plotted against the concentration of A. Click on the box which shows the graph that should be obtained. The graph of rate against concentration of A is a horizontal straight line as the rate is constant. Changing the concentration of A does not affect the rate of the reaction. Click on the rate button to see the expression. For a zero-order reaction, we know that rate is equal to the rate constant. Click K to find out its expression. Click Rearrange. To arrive at the integrated rate equation, click Integrate. On integration, we get concentration of A equals minus kT plus C, where C is an integration constant. When T equals 0, concentration of A equals concentration of A naught. Click on C. Click the Substitute button to introduce. The final equation is the integrated expression for zero-order reaction. The integrated rate equation gives us the relationship between time and concentration. We can use this equation to calculate the concentration at any point of time if the rate constant is known. For the reaction A gives X, rate equals K times concentration of A to the power n. If n equals 0, the rate of reaction is said to be zero order with respect to A. For a reaction that is zero order with respect to A, the rate is independent of the concentration of A, B, the rate is equal to the rate constant K, and C, the integrated equation of the rate law is concentration of A equals minus kT plus concentration of A naught. The integrated rate equation gives the relationship between time and concentration. We can calculate the concentration of A at time t if the rate constant is known.